In this video, I will explain what an IOTA seed is and how to create an IOTA seed. Please note, I am not a cryptographer, and what I explain in this video is a very simplistic view of things. The main goal of these video tutorials is to give the viewer some basic understanding how certain things works. An IOTA seed is 81 characters long and only consists of the Latin alphabet characters and the number 9, as you can see over here. The characters A to Z are all uppercase. With the seed, the IOTA wallet can generate corresponding addresses. Each specific seed generates addresses belonging to the seed. An IOTA seed looks like this. The seed is 81 characters long. According to the official IOTA knowledge base, this web page, you can use the following methods to generate IOTA seeds. On a Linux operating system, open a terminal and enter the following command. This command. On a Mac operating system, open a terminal and enter the following command. This command. On a Mac operating system, you can enter the following command. If you press enter, you will get this IOTA seed. Each time you enter this command, you get a different IOTA seed. The function /dev/urandom creates cryptographically random numbers by gathering random data, for example environmental noise, also called entropy, from device drivers, network package timings, and other sources into an entropy pool. The data from the entropy pool is used as input for the cryptographically secure pseudo-random number generator. This generator will generate the random numbers. The entropy pool gathers data from environmental noise. The cryptographically secure pseudo-random number generator uses the data from the entropy pool to generate random numbers. Some additional interesting information. Urandom means unlimited random. On the Mac operating system, there is no difference between /dev/random and /dev/urandom. Both behave identically. On Linux operating systems, there are differences between /dev/random and /dev/urandom. In this presentation, these differences will not be discussed. Another solution the IOTA knowledge base recommends to generate an IOTA seed is using this web application. It collects entropy by moving my mouse, as you can see here. When it reaches 100%, it will display the IOTA seed. Let's do it again. Moving my mouse. And here is another IOTA seed. The source code for this seed generator can be found at this location. The CNARS seedgen uses the Stanford JavaScript crypto library. This library can be found at this location. This is the JavaScript library. More information about this library can be found at these two locations. This last link gives more information about the API. This is the API documentation of this JavaScript library. The Stanford JavaScript Crypto Library is a project by the Stanford Computer Security Lab to build a secure, powerful, fast, small, easy-to-use cross-browser library for cryptography in JavaScript. The Stanford JavaScript Crypto Library is used in many web applications. Let's investigate the CNARS seedgen source code. This is the index.html file. Let's look at the raw code. The generator only consists of a few lines of code. It uses the Stanford JavaScript Crypto Library, as you can see over here. Let's investigate this JavaScript code. I have copied this code. I've pasted the code in an editor and add additional comments. Line 4 creates the generator. This value 10 is the paranoia level, which defines the quality of the randomness. 0 being the lowest quality good for testing only, and 10 being highest. Always use 10 and never use 0. Line 8 starts the built-in entropy collectors. It will fill the entropy pool with mouse movements. Line 16 to 20 is called every time entropy is added, meaning while moving your mouse. The progress P is a value from 0 to 1. While you move your mouse, entropy is collected, and when it reaches the value 1, progress is stopped, and this event is called. Lines 11 and 13 is called when the generator is seeded. It will call this function. This is this function. This is step 1. The value 33 is a number of random words to generate. There are 4 bytes to a word. In this example, 33 means 33 words. Each word consists of 4 bytes, and in total you will generate 33 words. This is word 1, and this is word 33. 10 is the paranoia level. So we have calculated this, and this is the second step. The second step convert the bit array, this array, to a base 64 string. And base 64 means a string containing these characters. So here's an example. If it will convert this bit array into this base 64 string, as you can see, this base 64 string only contains characters in this character set. The next step, remove all characters not belonging to the character set A to Z and the number 9 from this string. If you look at this string, the letter E is removed, the number 3 is removed, HD and plus sign is removed, E is removed, 2 is removed, and the plus sign is removed. And the fourth step is make sure that the seed is 81 characters long. And this is how the web application generates an IOTA seed. If you want to use the web application to generate an IOTA seed, do the following. Go to this web page and save the web page locally on your computer. Disconnect your computer from the internet, which means disable Wi-Fi or remove your Ethernet cable. Open the web page and move your mouse until it reaches 100%. The last step is store your IOTA seed in a secure location. So I will demonstrate it. You are at this web application. Save this web page. For example, on your desktop. Make sure your computer is not connected to the internet. Next, open the web page. As you can see over here, I'm using the locally stored file. I move my mouse. And this is the generated IOTA seed. And make sure you store the seed in a secure location. You should never create an IOTA seed by entering 81 characters yourself on a keyboard. You should never create an IOTA seed using a web application while you are online. And never use unknown IOTA seed generators. Use the seed generators recommended by the official IOTA knowledge base. There are several online IOTA seed generators which do not generate cryptographically secure random numbers, which means there is a big chance someone else can generate the same seed as you have. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.